In this video, we are going to answer this question. It's a redox titration, and we're going to find out the water of crystallization in ethanedioic acid crystals. Okay, so ethanedioic acid is a solid, and it's hydrated. Okay, if you want to have a read of that question, and then pause the video and try and work it out yourself, you can do so now, and then I will give you the answer before we do the working out. But the answer to this question is X is equal to 2. So there's 2 water molecules per molecule of ethanedioic acid. Okay, let's do it now then. Right, now we need to just think about the equations here. So the manganate, right, so manganate's the oxidizing agent, MnO4 minus 8H plus 5E minus goes to Mn2 plus and 4 waters. And the ethanedioate, well, that is, I'll do that in a different color. That's C2H4, sorry, C2H2, H2O4. That goes to 2 molecules of carbon dioxide, and we need 2 protons to balance it. So that means we need 2 electrons. So we have got a 5 electron process and a 2 electron process. So that means the molar ratio, well, we've got to times this one by 2.5, really, haven't we? So the molar ratio would be 1 mole of manganate to 2.5 moles of ethanedioate. So we will remember that for later on. Okay, now let's draw some little diagrams to see what's going on there. So what have we got? We have got a volumetric flask, 250 volume, and we put in there 1.78 grams of the hydrated crystals of the C2H2O4. As usual, we took out, so that's made of 250, we took 1/10 of that, we took 25 centimeters cubed out, put it into a conical flask, acidified it with sulfuric acid. Of course, we need the acid, the sulfuric acid, to provide these protons, and they titrated against manganate. Okay, so we had manganate in the burette. The concentration of the manganate was 0.02 moles per decimeter cubed, and we needed 28.2 of that to react. Incidentally, if you've done this titration like this in the lab, it's quite a tricky titration because this reaction between manganate and the ethanedioate is quite slow. So you have to actually heat this up to about 50 degrees C in a Bunsen flame before you start doing the titration. But towards the end, you don't have to worry about it being too hot because the rate of reaction gets a lot faster because you make these manganate ions. And if you've done this part of the specification already, the Mn2 plus ions are catalytic for this reaction. It's called an autocatalytic reaction, so the product actually catalyzes it. So it's pretty slow to start off with. You need to heat it, but once it gets going, you've got plenty of Mn2 plus, it's pretty quick. So at the end point, you don't need to keep heating it up. Okay, so just experimental details. Let's get on with the calculation. What can we do there? So again, sometimes people's first instinct is what we think, well, we know the mass and we can work out the moles of this, but we can't because we don't know the MR, because we don't know what X is. That's what we're going to try and find out. But what we can do is work out our moles of manganate because we know the concentration and we know the volume. So moles MnO4 minus then is equal to conc times volume. So that is 0.02 multiplied by 28.2 over 1,000. So that's going to be decimeters cubed, 0.0282. And that works out to be 5.64 times 10 to the minus 4 of manganate. Then we have to work out, how do we work out the moles of ethanedioic acid, right? Now look at the molar ratio. It's 1 mole of manganate to 2.5 moles of that. So we've got to do 5.64 times 10 to the minus 4 multiplied by 2.5. And that is going to give us 1.41 times 10 to the minus 3. And that's in 25 centimeters cubed. But we took 25 out of this total volume of 250. So how many moles of have we got in 250? So moles of the acid in 250 is equal to that times 10. That is equal to 0.0141 moles. Okay, now we know the number of moles and we know the mass because look, we had 1.78 grams, you know, so we can work out the MR. Okay, I'll do that over here. So the MR, moles, is equal to mass over MR. So the MR is going to be equal to mass over moles. The mass, we're told, was 1.78 grams. And the moles we calculated is 0.0141. So we'll do that, and that gives us an answer of 126.2. Okay, so now we should be able to work out the moles of water there, because look, if we write down the formula of our ethane dioate, it is C2H2O4XH2O, and that's equal to 126.2. So the whole thing is 126.2. Right, we find out the MR of all that bit. So 2 times 12 plus 2 for the hydrogens plus 4 times 16, that gives us 90. So that means the mass of the XH2O is going to be 126.2 minus 90, which is equal to 36.2. How do we find out X? Well, each water molecule weighs 18. So X is equal to 36.2 over 18. Right, so that is equal to 2.01. We know X can only have integer values, so the value for X is 2. The water crystallization is 2 molecules of water. So the formula is C2H4O4.2H2O. There's our answer.